Hello, so we're going to do significant figures today. This is Module 1, Lesson 3, or 1.03. And significant figures has been abbreviated to sigfigs. Now notice we did not do a ton of content live in 1.01 and 1.02. That's because the main meat of that is in the Canvas lesson. So just make sure you go back to that to get the other parts of 1.01 and 1.02. So sigfig rule number 1 is non-zero numbers are important. And that means any number 1, 2, 3, 4, 5, 6, 7, 8, 9. Those guys are always significant. Now, zeros are placeholders, so they are important placeholders, but they're not always significant for how important your problem statement is. Rule number 2, zeros have lots of different rules depending on where they are. Leading zeros, so when you think leading, think left. Leading zeros are on the left of the first non-zero. So if I read from left to right, I have a 5 here as my first non-zero number. So I'm going to underline the 5 because that guy is significant. Non-zeros are always significant. And then all the zeros to the left of that 5 are called leading. Leading are never significant, so they're not going to get any underlines there. Contained zeros are always significant. Contained means they're trapped between two non-zeros. So we have a 5 and then we have a bunch of zeros and then we have a 1. So all those zeros between the 5 and the 1 are contained. And they are all important. So those guys are going to get underlined. Okay, and I just have them showing green right here. And red for not significant. Leading are not ever significant. Contained are always significant. And then we get to our trailing. Trailing has an R in it for on the right. Trailing zeros are on the right of your last non-zero. So 2 is my last non-zero when we read left to right. And so those last zeros to the right of that are our trailing zeros. And they are sometimes significant. So this is the one you have to pay attention. If you see a decimal, then it's significant. And notice my decimal is way over here on the left. It does not matter where the decimal is. If you see a decimal, it is significant. So we're going to change those to green. So my number is 0000.0005 0.0000000001200000. Those leading zeros are not significant. They're still important to tell us that it's not 0.5, it's 0.0005. So we don't underline them, but they are still placeholders. We underline everything else that was green, and then we count that up, and we notice we have 17 total things that we underline. So 17 sig figs. So those are your rules. So when we look at this, I see this number here of 123,100,000, but there is no decimal. Just because we know that there should be a decimal at this last point doesn't mean that there is one, because why? It's been rounded, so it's not as exact. So it's not as significant. So we still follow the same rules as before. We're going to underline our 1, 2, 3, and 1 because they are non-zeros. We are going to underline our trapped zeros because they're between the 3 and the 1. And then we're going to evaluate. Remember, on the right is called trailing because trailing has an R in it for right. Everything to the right of that last non-zero, we need to decide, do we see a decimal? No decimal, so those guys are not going to be significant. So we are not going to count them in our underlines. So our first set of underlines does work. And we have 7 total sig figs here. The 1, 2, 3, 0, 0, 0, and 1 are significant. So let's try these ones out. What do we know? we need to figure out our non-zeros. So let's underline our non-zeros, the 5 and the 7. And on this right one, the 1 and the 4. Do we have any leading? Leading means what? Leading are on the left. Do we have any on the left? For the first number of 570,000, there are no leading, so we don't have to do anything with it. For our second number, 0.001040, we have zeros to the left of the 1. Those guys are leading. Are they important? Nope, so they get no underlines there. What do we look for next? Any contained or trapped? The first number, 570,000, has no contained or trapped zeros. But on the right, we have a 0, just 1 0 between the 1 and the 4. So that now gets an underline. Okay, contained are your trapped. And what's the last set of zeros? Are the trailing. Trailing are the ones that are on the right. Okay. So 570,000, I see a decimal there. So that means they are significant. So every single one of those zeros on the right is going to be underlined. Those are all trailing zeros. So that has how many underlines? 1, 2, 3, 4, 5, 6, 7. So there are 7 sig figs in the number on the left. On the number on the right, we also have a trailing. It's to the right of the 4. There's only 1. And now this guy has 4 sig figs when we count up the underlines. Now, when we do multiplication and division, you have to calculate the answer before figuring out the sig figs. Okay. Now, we do need to know order of operations. This one is multiplication and division. It was given right there with you because we're doing a sample problem, but you do want to think about that first because multiplication and division has different sets of rules. So I'm going to plug all this into my calculator, 2.05 times 1100 times 0.00230 divided by 4.00 times 10 to the 4th. Notice this has parentheses. If it does not have parentheses when you write it, still put parentheses when you put it in the calculator or it's going to mess up your order of operations. So when I calculate my answer, I get 0.00012966625. You probably want to also calculate just to make sure you do know how to put it into your calculator so you don't make any silly mistakes on the quiz. And then step 3, count the sig figs of each number. 2.05, that has 2 and a 5 as significant, and the 0 is trapped in between there, so that is 3 sig figs. 1100, the 1 and the 1 are significant, but I don't see a decimal, so those other 2 are not significant. My next number has a lot of leading zeros, which are good for placeholders, but those are not significant. The 2 and the 3 are significant, and the 0 to the right is trailing with a decimal, so that is significant. Now, scientific notation we didn't go over, but if you think about it, scientific notation just means that's a placeholder. So while we need to know that, because 40,000 is totally different than 4, we don't need it for significance. For significance, we're just going to look at before the x. And those zeros, in this case, are before the x because they are trailing with a decimal. So what do we have? 3 sig figs, 2 sig figs, 3 sig figs, and 3 sig figs. Okay, so we counted the sig figs in each one. So now step 4, round the answer to the least sig figs. So that is 2. I'm going to be rounding my answer to 2 sig figs. How do I do that? Underline the first 2 sig figs of your answer. These guys here are leading, so we're not going to use that. So we're going to look, and 1 and 2 are our first 2 significant. So we look at the 9. The 9 says we have to round up. Now I'm not just going to write 130 as my answer. Okay, 0.000129 is super small. 130 is a lot bigger. That would not be my answer. So don't forget, you still do need those placeholders later. So my answer is going to be 0.00013. as my answer. When you are doing these problems, write down the calculator answer in your work and then write down the final answer in your work so that I can give you partial credit on the assignments if you just messed up on your rounding. Addition and subtraction is not actually sig figs, it goes by decimal places. So 124.0100 has 4 decimal places. And 10.5 has 1 decimal place. We round to the least number of decimal places. So we're going to round my answer to 1 decimal place. And finally, on these try thises, feel free to just pause on the recording if you weren't in the live session, and then try it out on your own and then see what the answers are at the end. Okay. 2 sig figs, 3 sig figs. This is multiplication and division. So we round to the least sig figs. So we're going to round to 2 sig figs. There's my calculator answer, 3 times 10 to the negative 11, but I need 2 sig figs. So I'm just going to add in a sig fig. So I can just go 3.0 because in math, 3 or 3.0 or 3.0000 would all be the same value. But 3 is less significant than this guy. This guy is more exact. And we have to know how exact our measurements are to see how important it is our data is. And the guy on the right, I notice I have 2 things. I have addition and subtraction. So this part goes by least decimal place. And the divided by here is going to tell me that overall we're going to go by least sig figs. So if you get any one of these, you have to do them in 2 parts, just like you do your PEMDAS. So we do this first, 1 decimal place, 2 decimal places. So that answer needs to be rounded to 1 decimal place. And that gives us 3.5. So 3.5 is our numerator, and now we divide it by 0.0123, and that gives us 284.55. And now, what's my least sig figs? I have 2 sig figs and 3.5, and 3 sig figs and 1.23. So we're going to round it to 2 sig figs for our answer. So that was real quick for the end of day 2. What's actually due today is 101 and 102, and then take notes on 1.03 to really firm up what we did in class today. And then we will continue on tomorrow. And have a great day.